Okay, we're going to change it up a bit today and do some word problems as you saw in Mr. Walker's video. So let's take a look at 4 word problems together today. The standard is I can solve word problems involving the addition of measurement and decimal form. So barrel A contains 2.7 liters, 2 7/10 liters of water. Barrel B contains 3 900 liters of water. Altogether, how much water do the 2 barrels contain? So together means we're adding them. 2 7/10, 3 900. Let's write them as a fraction to solve this. What do you say? 2 7/10, 3 900. Let's make the 7/10 70 hundredths, and let's add them, and we'll put it in decimal form. 3 plus 2 is 5. 70 hundredths plus 9 hundredths is 79 hundredths. So 5 79 hundredths liters of water in the 2 barrels. Okay. All right. Number 2. Alyssa ran a distance of 15 8/10 kilometers one week and 17 34 kilometers the following week. How far did she run in the 2 weeks? So we're going to add them together again. I'm going to write them out as fractions first. 15 8/10 plus 17 34 hundredths. Let's make this 8/10 80 hundredths. Okay, add our whole numbers first. 15 plus 17, that's going to be 32. If you need to add it out, writing them in an addition form, that's fine. 80 hundredths plus 34 hundredths. I'm doing it in my head. If you need to do 80 plus 34, then do it. That's fine. 80 plus 34 is 114 hundredths. Let's decompose it just like yesterday's lesson. That's going to be 100 100ths and 14 hundredths. So 32 and one more would be 33 and 14 hundredths kilometers. In 2 weeks, she ran that far. That's a lot of running, isn't it? Okay, 2 more. An apple orchard sold 140 5/10 kilograms of apples in the morning and 15 85 kilograms of more apples in the afternoon than in the morning. How many total kilograms of apples were sold that day? That one tries to trick us. They didn't sell 15 85 hundredths kilograms in the afternoon. They sold 15 85 hundredths kilograms more in the afternoon than they did in the morning. So we don't know how many they sold in the afternoon. We've got to figure that out and then find out how many total kilograms were sold during the day. So let's start by writing this first problem out. They sold 140 5/10 kilograms of apples in the morning. And they sold 15 85 kilograms more than that. 15 85 hundredths kilograms more than that in the afternoon. So this is the morning. We know that's the morning. And we're going to add these to this to find out how much they sold in the afternoon. Morning is this, and they sold this much more in the afternoon than in the morning. So let's add this to this. So 50 tenths is 50 hundredths. So let's add our whole numbers first. 140 plus 15 is 155. 50 hundredths plus 85 hundredths is 135 hundredths. We've got to decompose that. 100 hundredths and 35 hundredths. So that's one more. So 155 and one more would be 156 and 35 hundredths. But that's not the answer. That's how much they sold in the afternoon. They sold this much in the morning. They sold this much in the afternoon. How much were sold in all? So now we've got to take our morning sales and our afternoon cells and add them together. So 140 and 50 hundredths plus afternoon, 156 and 35 hundredths. And we're going to get 140 plus 156. If you add them together, you're going to get 296. Add our fractions. 51 hundredths plus 35 one hundredths would be 85 hundredths. Let's write it as a decimal since it's decimals in the problem. 296 and 85 hundredths kilograms of apples in the whole day. So just walking through that again, we had to find out how much they sold in the afternoon. It told us how much more they sold in the afternoon than in the morning, but we didn't know how much they sold in the afternoon. We had to find it. Then when we found how much they sold in the afternoon, we had to add that to how much they sold in the morning to find out how much they sold all day. Quite a few steps in that problem, wasn't there? You have to think through these. The last one. A team of 3 ran a relay race. The final runner's time was the fastest, measuring 29 and 2/10 seconds. The middle runner's time was 1 and 89 seconds slower than the final runner's. The starting runner's time was 9/10 of a second slower than the middle runner's. What was the team's total time for the race? Okay. My brain says slower equals subtract, but that wouldn't be right, okay? So if I'm running and I ran the fastest and I had 29, and I'm taking this number right here, the fastest time in 2/10, okay? That's the fastest time. So the number, if somebody is slower than that in a race, it wouldn't be less, would it? You wouldn't subtract. You would add time to that. So if the fastest runner was 29 seconds, they obviously got in first place. So the person who got second place wouldn't get there in 28 seconds, would they? Because that would be faster than the first runner. So we're going to add this time to see how much slower they were. The middle runner's time was 1 and 89 seconds slower than the final runner's. The final runner's time was this. So we're going to add 1 and 89 seconds to this to see how slow, how quickly, whatever you want to say, the second runners ran the race. That's hard to say, okay? We're trying to find out the speed, the time of the second runner. Here's runner number 1, the final runner, okay? F for final runner, okay? There's a lot of confusing words in this word problem. Why would the final runner's time be the fastest time? That sounds like he was the final one that came in. But anyway, confusing. Add these. 29 plus 1 would be 30. 20 hundredths plus 89 hundredths would be 109 hundredths. Decompose. 100 hundredths, 9 hundredths. Add 1 to that. 31 and 9 hundredths. Okay. So this is the middle runner's time. This is the final runner's time. This is the middle runner's time. The final runner ran it in 29 and 20 hundredths seconds. The middle runner ran it in 31 and 9 hundredths seconds. The starting runner's time, oh, this is a relay race. I see. That's why I'm thinking these 3 people are racing against each other. I just got it now. The starting runner's time was 9 seconds slower than the middle runner's. So we're going to take this middle runner's score, 31.09. We're going to add 9/10 to it. 31 and 9 hundredths plus 9/10. It's going to be 90 hundredths. So add this amount of room. It's going to be 31 and 99 hundredths. Okay. What was the team's total time for the race? So this is the starting runner. Okay, starter is 31 and 99 hundredths. The middle runner is 31 and 9 hundredths. The final runner is 29 and 20 hundredths. We've got to add all three of those together to find out their total time. So I'm going to start with the starter. 31, let's write all these in fractions, and 99/100ths. Now let's do the middle runner's time. He scored 31/900ths. Now I'm going to add the starter score. The final runner score. Whew. I've struggled with this one, haven't I? 29/20. Okay. So you could add these one at a time if you wanted to. You could add them all three at the same time. So I'm going to add them all three at the same time to save me a step. 31 plus 31 is 62, and 29 more. Add these. 2 plus 9 is 11. Put my 1 down, carry my 1. 1 plus 6 is 7, plus 2 is 9. So my whole numbers added together are 91. Now I've got to add my numerators here on my fractions. They're all hundredths, so I don't have to change anything. 20 plus 9 is 29, and plus a 99. Add these. 9 plus 9 is 18. Put your 8 down, carry your 1. 1 plus 2 is 3, plus 9 is 12. So 91/128 is their total time, but we got to decompose this. 100 hundredths and 28 hundredths. This is one more. 91 and one more would be 92. We're almost done. And 28 hundredths seconds. Wow. That one almost confused Mr. Help. That was a lot of work in that, and I kept getting confused about the runners. So take your time on that last one. Think through it. Label it, draw pictures, whatever you need to do to help you solve it. That's probably your last one's probably going to be pretty tough like that one was. But I know you can do it. You're a bunch of smart boys and girls. Get on it.